All right, we should be live here. Let me just double check some things. And folks in the chat, let me know if you can hear me just fine. All right, cool. Looks like I'm gonna try and use low latency. Hopefully the delay on that is not too bad. Let's see, how many people do we have in this stream right now? 6 people, might just wait a few more minutes. How's everybody doing? I think my audio might actually be a little too quiet here. Let me see if I can bump that up. Seems like OBS doesn't let me increase it. Let me see. Move this closer. Maybe that'll be a bit better. Oh, that sounds about the same. One moment, please. Okay, that should be a pretty substantial boost there. That's, this delay is really a killer. That's life, I guess. Okay, I think I'll boost it up to that and just kind of leave it there. Boost it up to that and just kind of leave it there. Wow, we got 11 people now. All right, cool. I am going to get started. So, gonna be pretty chill stream, I think. Gonna be a new project that I'm working on. So the watch, which I'm sure most of you already seen, and is horrible state right now as I do some things. Took a lot of work, I think, as you all know and you can all tell. But a lot of that work was, I think, reusable. So I'm going to build something based off of that. So a lot of the work I did to miniaturize the circuits, build the LCD driver, all that kind of stuff. I want to take that and I want to repurpose that into a keychain sized Game Boy Color, which I'm sure there's a lot of people, maybe not here, but I'm sure there's a lot of people who are disappointed that it's not the Froggo Advance immediately. That's going to be a much longer term project, but I do plan on working on that, and I have some exciting ideas for it. So I think I shared a prototype kind of sort of thing that I had designed and printed out a little while ago, maybe 2 years at this point. Totally different from that. So starting fresh, because I think we need to pump some more unique energy into the scene instead of just kind of doing the same thing over and over again. But yeah, so today's plan, I'm going to be working on what I'm dubbing the Egg Boy Color, which will complete the line of Frog Boy, Tad Boy, and now Egg Boy. So big guy, littler guy. And the idea is I want to have it on a keychain so I can rock my watch and play my keychain Game Boy and bring all my other Game Boys with me. It's going to be great. It's going to be awesome. So I'm just going to be kind of like doing the CAD for that. And I am not an expert by any means. So, you know, like maybe you can pick up some tips and tricks. I wouldn't necessarily look to what I do as like best practices. But, you know, if you see something interesting that I've done, happy to expound upon that. And of course, you know, use that if you think it's useful. So let's just get started. So I've done no work on this. So this is actually intended to be my project for the BitBelt Summer Contest for 2026. So this is something I'll probably be working on for, 2-3 months maybe. Haven't started, this contest just started, I can't use any previous work for the most part outside of, some basic things that are already available to people. So like my LCD driver software, going to reuse that. That's basically it. So I'm starting fresh here on the shell design. And one of the things on the TFC that I'm not super happy about is the screen. So the screen that I chose it's small, it's watch sized, but it's a 240 by 240 panel. So no integer scale, it's a 1.5x scale. I think at that size, it kind of looks okay. I think for the shit post of a project that the TFC is fine. Like I don't think I really require anything beyond that. But I want this to be more of a practical device. And so I am going to, and I haven't written any software for this or adjusted my software for it. I'm going to be switching to this slightly larger panel. So this is I think it's 1.54 inches, something like that. 320 by 320. And so I am going to be able to get a nice clean 2x scale from 160 by 144 to 320 by 288. I think that math works out. Why am I bringing this up? Because that's what the design is all based around. So reasonably confident that, given the fact that this panel is more or less the same size as the watch, I will be able to base sizing on this. It shouldn't be constrained by the CPU and the RAM and all that stuff, the stuff that goes onto the motherboard. Hello, laser. Welcome. Shouldn't be constrained by that. So I think main constraint here is going to be the screen. I do need to keep in mind that I want to have a battery in this. Not entirely sure yet whether or not I want to include a USB-C port for charging. I'm thinking I might actually go for like a magnetic thing based on pogo pins, something like that. It really just kind of depends on where I take the design and whether or not I want to like keep things as small as possible. But yeah, let's go ahead and get started. So I'm just going to start off by taking some measurements for my screen here. Actually, first I'm going to create a sketch. All my stuff in Fusion, I start with sketches rather than primitives. This kind of helps keep things together. So I'm going to start by, I think, just modeling the screen. So this is 31.34 by, let's see, 33.5. Okay. So I'm going to create a square. Let's see, what did I say? 31.34 by 33.5. Those directions are actually reversed. Actually, 31.34. Okay. All right. And then this panel is, how thick is this? I just got my calipers here. So it's exactly 1.5 millimeters. It's a nice skinny panel. So let's see, we're just going to extrude that by 1.5 millimeters here. Let's see, I do want to make sure I get the viewable area properly accounted for in the screen cutout in the shell. So I'm also going to measure the thickness of the sort of plastic bezel around this thing. So it looks like it's about 0.5 millimeter all the way around. I'm actually going to go back into my sketch here. Let's see. I am going to, and we're just going to do this. So I'm going to create a little square up here, 0.5 offset from the corner. Going to make these construction lines so that they don't affect Don't affect my extrudes. I'm gonna add a center line here actually, just so I can mirror this feature. All right. So we're gonna mirror this little corner. Let's see, I think it already, yeah, it automatically picked up the center line there. All right, so that's gonna be our constraints for the little bezel part here. So let's see, that's 30.34 wide, so 30.34 square screen. So I don't think it's not super important for me now to decide like where on the screen I'm actually going to display the image, because that's always something I can adjust in software. Like if it's a little bit off in the CAD vertically, like just by a little bit, it shouldn't be a problem at all. All right, well that's nice. My extrusion's still done. Let's see, let's make the sketch visible again. I want to, I'm actually going to make that negative so that my sketch is on the top side. There we go. And then I think just to kind of clearly delineate this, I will inset this by 0.2 millimeters or something, just so it's super clear and I've got some reference geometry to base things on. So that box there, that's roughly the viewable area for this panel. You know, just kind of looking at it up close, that seems to match pretty well. So we're going to start with that. I am going to just go ahead and create a component from this. And I definitely don't have good fusion. What would you say? You know, whatever the word is. I'm not good with fusion. No good, no good. But we're going to call this, so LCD. Alrighty. Oh, and actually I'm going to go ahead and create a new project. So let's just say egg boy color. Let's go ahead and just save this. You know what, I'm actually just going to keep this file specifically as just the LCD. So we'll say EBC LCD. All right, and then we'll just import that into a new thing. I don't think that's saved where I wanted it to. There we go. There, it's showing up now. All right. You probably can't see it, but there it is. Put myself down here. Nothing's really in the corner here. All right, so let's go ahead and create a new design. I'm going to do a hybrid because that lets me have bodies and components, all that stuff. I haven't really gotten into all the assemblies and stuff for Infusion. I'm sure they would be super useful and they would keep my timelines from being a complete mess, but I have absolutely no patience for that, so we're not going to do it. Just going to drop my screen in here, so that's going to be our reference for the front shell, which is going to be the first part that we're going to tackle. So let's see, I'm just going to start with a sketch that's sort of in the same plane as the screen here. And then, so I'm going to project two things. I'm going to project this outer wall. Yeah, I think I can make this easy. I can just project this whole part. I'm going to project this whole face. That way I can use these as a reference in my shell design. So the outer perimeter is obviously going to be, you know, like where the LCD is going to be sitting, and then the inner one is going to be where the viewable area is. I don't think that's going to be much of an issue for the shell itself. I think that's more of something that'll come up when I design the lens for this. So this will have a custom glass lens. You know, it's just kind of my thing at this point, I feel. And so where do I want to take this? So let me just grab the watch real quick. I just need a sanity check. Yeah, so I think I'm going to make this thing the same width as the watch. I don't remember exactly what that is. So let's open up my TFC files. There's a million of them. Oh God. And I am still trying to figure all this out because all these files are in various states of organization and of readiness. So I'm trying to figure all that stuff out so I can open source all the files. I have started the GitHub repo for the TFC. You can actually go to my GitHub and you can see it right now. So there's some shell files. There's some, what else did I put up there? I think all the buttons, that kind of thing. That's basically all I've got for now. I still need to do like technical drawings and stuff. But it will be done at some point. So let me see, how wide is this? I think it's like 38. It's 38. I think that's the exact number I threw out in the video too for the TFC. All right. Oh wait, no, this is the LCD file. I don't want to edit that. All right, so we got our sketch here. I am just going to, I think I'm going to assume from the center point of the viewable area here. So I'm going to create these construction lines. All right. Just going to create a point at the center here. Just so we know where the center of that is. Going to create a centered square here. So let's just start out. So 38 millimeters by 38 millimeters. All right. And let's see, how much of a gap does that give me between the top of the shell and, yeah, 2¼ millimeters. I think that's actually, that's perfectly fine. That'll work great. Cool. All right, so we need to extend this bottom bit a little bit. Obviously, you know, I'm gonna wanna have controls on this thing. This is meant to be at least somewhat practical. So let's go ahead and just create a control block here. I'm thinking, oh man, how much space am I gonna need? Let me grab my box of TFC motherboards just so I can grab some chip measurements real quick. I have like two prototype TFC motherboards just chilling, all populated and stuff. Oh man, it's not in this one. I must put it in the other one. Ta-da, there we go. All right. So let's see, I think, trying to think here. So let's see, the CPU and the RAM, they'll go on the back side of the motherboard, I think, because we'll want buttons on the front. The total height of those is about 22 millimeters, okay. So I think we'll just make this bottom part, we'll go on the safe side, we'll say 30 millimeters. I can always adjust that. No, that looks weird. I'm gonna go 25. I think that's a better, yeah, I think that's a better ratio. I could also widen it just to get a better ratio, but I really want, like, you know, smallish bezels. Yeah, that should be fine. I could probably go down to 22 even. Wow, this is gonna be, I think this motherboard might end up being smaller in some respects than the TFC one. All right, so that's kind of the basic thing there. So let's just go ahead and start with that. Like I mentioned, I'm not super great about these things. So, you know, I think a lot of people would plan these things out better, and they would, you know, more or less have the design baked in with parameters and stuff. You know, maybe they'd even include their like fillets and things. I don't know exactly where I want to take this yet, so I can't really do that. So I think, let's see, this device will be, I think it'll be about the same thickness as the watch body, the TFC watch body, which is right around 15 millimeters. So we'll just split the difference on this, I think, for now. We'll say this is going to be 7.5 millimeters thick, so we're going to start with that. I'm going to do a shell operation on this. Let's see, so we're going to start with that face. We'll say maybe wall thicknesses of 1.5 millimeters. I think that should be pretty good. All right. Actually, you know what? Before we do that, I'm going to throw some fillets on these corners just so I don't have to account for those when I later on after the shell operation. So let's see what looks good. I think 3. You know what? I think I actually want, I think 3 on these top ones is good. I want slightly larger on the bottom. I'm thinking something reminiscent of the Tad Boy. One of the things I was kind of going back and forth on when kind of doing some of the basic brainstorming for this was, do I want it to look like a tiny Tad Boy, or do I want it to look like a tiny Game Boy Color? And I think I'm gonna go for tiny Tad Boy. I think that's more on brand. All right, let's pull this screen back up here. Components. Unground from parent, God. Okay. Let's see, we're gonna pull this up. All right, oh, that's actually flipped upside down, so let's 180 that. Okay, and then, yeah. Oh yeah, that'll fit in nicely, look at that. Okay. Cool, cool, cool. Don't know exactly where this will sit right now. I'm thinking that this front section, I could probably actually keep the front section at 1.5 millimeters. I think the whole thing just 1.5 millimeter wall thicknesses all the way around. And then probably 0.8 millimeter lens. I'm trying to think of some of these things early on so I'm not having to like change a bunch of things later on. It doesn't look like a Tamagotchi to me. Well. It would be fitting, I think, for the egg boy to look like a Tamagotchi, but I don't know if I shall do that. All right, I think that's roughly where the LCD is going to sit. Let's go ahead and get a cutout for that. Let's see. So let's get an inner sketch going on here. Gonna project just the back of the LCD. All right, I'll turn that off. I'm just gonna cut this all the way through. That's looking good. And then I like to keep CNC machinability in mind from the start. So these hard corners do not work. They will not work. So what I'm actually going to do is I'm going to create, I think, what they're called dog bones in the corners here. So that's basically where you can take your circular cutting tool and you cut, slightly outside of your bounding box. And so your sharp corners can fit in there. And you just have like these little small relief areas left on the side. Pretty common trick. It's something that I used on the watch. I don't think I used it on the Tad Boy because that one was, the way it was designed, like you could, do all the milling the way it needed to be from both sides. But for this one, I'm just going to go ahead and make a decision now. It would be wise of me to actually mirror this. Oh, hygiene, fusion hygiene. That's what I was trying to say earlier. I need better fusion hygiene. All right, so we're gonna mirror this one across this vertical line, and then we're gonna mirror both across this horizontal line. All right, so we got our dog bones in there. If I was smart, I would have extruded those all out at once. Actually, you know what? I'm a silly man. This is how my projects end up taking way longer than they should. I'm always like, yeah, just cowboy, whatever. And then I change one thing and my whole timeline breaks, which is horrible and bad. Sweet, look at that. All right, let's go ahead and tackle a lens area here. So let's go ahead and create a new sketch on the front. It looks like our screen is in fact aligned with the center point of the workspace here. I don't know if I really want to rely on that. I will, because I'm crazy. So let's see, how about 36 by 36? That looks great. One of the benefits too. Well, looks good here. Probably a 2.5. Those are 2.4. Yeah, okay. One of the things I thought initially was like, oh, I can just reuse the same screen from the TFC in this thing, and then I can like use the same lens and I can call it something, the Tamagotchi frog color, who knows, something that matches the TFC acronym just to match the lenses. But then I was like, I want proper integer scaling, so I'm just going to kind of abandon that idea. So there we go. So now we have a 0.5 millimeter inset there for a lens. I will make the decision later on whether or not I want that to... actually, you know what? This needs to be smaller now that I think about it because I am going to want to add some edge rounding, and there's not going to be any space for edge rounding. So let's do maybe 34 by 34. Yeah, that should be good. That still covers the whole thing. There's a little bit of stuff on the sides to stick to, so that shouldn't be a problem. Yeah, I'm just trying to avoid... areas where I might leave like awkward gaps. Maybe 35 by 35. I think that's better. I think that's, yeah, I think that'll be better. All right, so let's redo these chamfers. 2.4. Yeah, so that clears the dog bone just fine. Because basically what I'm trying to avoid right now is having, so you have the lens on top of the shell, and generally on all of the visible edges around the lens, because it's not going to fit perfectly, there's going to be some tolerance there. I want there to be solid metal or whatever visible through that gap instead of like seeing directly through to the internals underneath. I think it just kind of looks cheap. That was one of those things I wasn't really a big fan of with the, I think the Funny Playing laminated GBA screens, because of the way they had to like sort of go into their custom shell. It was just left with a weird, unpleasant gap that I was not a fan of. I mean, they're still cool screens, but you know, not my personal cup of tea as far as things go. Everybody knows that frog eggs are rectangular rather than eggular. I shan't say no. All right, look at this. Hell yeah, all right. Let's see what kind of fillet we can get here. That'll look good. Just take it right up to the 1.5 maybe. That's kind of weird. It's kind of weird. But it's also small, so I don't know if it's a big deal, really. I don't necessarily like this. I kind of wish those were more, I don't know what the term is, parallel along the curve, so to speak. Yeah, I mean, we'll go with that for now. If it ends up being a little boxy, it ends up being a little boxy. Cool. Let me go ahead and just get a quick, let's see. Yeah, okay, so I'm gonna also, out of this sketch, which one was it? Is it that one? It's that one, okay. Out of this sketch, I am going to extrude a lens. So I think I want to go with not a 2.5D one on this one. I think I want it to just be flat. And I think I'll just have it flush with the body. So 0.5 millimeter thick lens on that. That went the wrong direction. Negative 0.5. And I want it to be a new body. Okay. And then because I need some clearance, I'm going to go ahead and give this an offset. You know, I plan this for this to be CNC machine, so let's just go for like a 0.05 millimeter tolerance all around the edge there. So we'll have just a teeny little gap. Probably won't work great for any 3D prints that I do as tests. Oh, that didn't actually go all the way around. God, kill me. If there's any Fusion 360 legends in the chat who know how to select all this shit automatically, please let me know. All right. All right, now we should have, yeah, looks like we have a nice even gap all around now. I might actually do 0.5D or 2.5D on that. God, how would that look? Okay, that's what we're doing. I think that's nice. Okay, let's go ahead and create a component for this. So EDC lens. All right, and let's see, how are we looking so far? Got our little LCD in there, we got our lens. Let me go ahead and do a section analysis. So this is gonna let me do a cross section just to make sure I don't have anything overlapping by accident. Yeah, so it looks like everything is good here. One thing I do need to do is I need to add a little bit of a tolerance in the screen cutout, because right now that's a perfect fit. I actually have a data sheet for this screen, which I probably should have looked at instead of just like measuring things on my own. Let me pull that up here. All right, here we go. So here's the data sheet for it. Not a whole lot in it, but it does have dimensions. Let's see if, okay, cool. 33.72, actually. Interesting. 31.5. I did get that one right. Plus or minus 0.2 millimeters. That seems like quite a large tolerance, but I think that is like an injection molded plastic part that goes along the outside, so maybe I shouldn't be too surprised about that. 33.72. Actually, I think I measured 33.74 on that one, didn't I? Let's get the lens off. So I think the tall one was this direction. How big is this? 33.5. Okay, so that does actually need to be adjusted just a little bit. And then this one should be 31.5, I think. 31.34. What? Okay. Well, let's see if we can go back to our original. No. Okay. Let's see what happens if we adjust the original. All right, 31.5. And then this was 33.75 roughly. Okay. So the screen, that adjusted nicely. I think, yeah, all that stuff is nicely. Hey, yeah. Jeez. Okay. This is where things start to go off the rails. How far off is that? Let's see, because I think it's supposed to be a 0.5 millimeter. It's 0.08 millimeters off. 0.8. 70.5. Okay, yeah, that's good. Okay. That's right, HDR. No F1 for you. Let me double check that this one is. That one is correct. Okay. So save that file. Let's hop over here. Haha, frog joke. Rest in peace, Warner. We will. Let me go ahead and fetch the new one. Fingers crossed, this will pick up on the changes, and because my sketches were based on that geometry, it'll actually look correct. Okay, nothing broke. The timeline's all good, so no yellows, no reds. That's good. Let's check on our dimensions here. I mean, it could be that it cached those dimensions. Oh no, 31.5. Okay. And then 33.75. Wow. So, yay, early days. So I can actually make these changes and it's not just gonna all just go to hell. Oh my God. All right, let's see. How far behind is this video? Oh, I was watching something entirely. Brain freeze. Okay, cool. So yeah, what was I doing? So I was creating some tolerances for the screens. So the data sheet did say plus or minus, I think it was plus or minus, right? Plus or minus 0.2 all the way around. So that's what we're gonna do. And then on the technical drawings for this, I'll just say like it has to be a minimum of this size. So it's gonna be a plus tolerance instead of a plus minus on my side. All right, so we're gonna just offset the face there. So negative 0.2. All right, still room to get tools in there. I think this is actually gonna get milled out from the front, just thinking ahead, because that would be pretty deep for, well, no, actually, because that's a roughly 2 millimeter diameter circular area there. So I could actually get like a 7 or 8 millimeter, like 2 millimeter, or 7 or 8 millimeter cutting length, 2 millimeter diameter end mill in there. So that's not a problem. And I can also just tackle it from the front if I want to. All right, let's see. So I think, let me just double check. How much distance do we have from here to here? So we got a little over 25 millimeters, so that's fine. I should be able to squeeze all the electronics in for that. Oh, I have to think about that though, because I need the... No, it should be fine. It should be fine. Okay, yeah. So the idea here is that the PCB, it's going to be a single PCB. It's not going to be a sandwich because we don't need to do that, and because I want to fit a battery in here. Excuse me. So it's going to be a single monolithic PCB. I think basically all the Game Boy circuitry is going to be down in this area below the screen. And then I think everything else, so the LCD driver and all the power circuitry will be, excuse me, on this end of the board. So it's going to sort of sit right behind the LCD. I think I should have enough space for that. That should not be a problem. So I think I'll be good here. So now I need to decide, do I want to start working on kind of PCB related stuff? Do I want to go ahead and get that shape and whatnot locked in? Do I want to work on the back, or do I want to work on buttons? I think buttons are important. So let me go through. Let me just go ahead and rename my sketches. Lens, cutout, just so I can keep track of them. Let's see, LCD dog bones, I guess. LCD cutout. This is more than I normally do, by the way. No, we'll just say front base or something like that for the sketch names. Let's create one more sketch here. I'm a big fan of a million small sketches that I can't keep straight, so, you know, something's wrong with me probably. Let's see. I think what I'm going to do is I'm going to create a circle just to sort of work out where the D-pad should be. Let's see. I want it to be as big as I can get it reasonably. I think 14 by 14. That's about, how big is that? How big is my little nubbin on the TFC, the little D-pad nubbin on here? Oh, this is 8.5. Oh yeah, man, 14 by 14, that's huge. That's gonna be great, okay. I think that's a little too far over though. Maybe. Let's see. Let's just move it here. Let's do 14 by 14. Yeah, there we go. Okay. So I'm going to make that a construction line because I don't actually want that to be the shape of the D-pad. But now that I think about it, and maybe people here have opinions, I'm thinking about whether or not I want to have a tiny actual D-pad for the looks, because that captures the whole Game Boy aesthetic, and that's kind of the whole point. And I already have like a million different practical Game Boy colors I could actually play. Or I can make it a circle, which I think would actually be easier to use at that size. I can always change it later if I want. So I think I'm going to start with just a D-pad. Let's see. So let's say that the central part is going to be... Yeah, I think the way I'm going to work this is, so let's say 5. So that's going to be kind of like the inner core. And then we'll have it come out from here. Is that actually 10? Yeah, okay, that is. Okay. All right. Let's just have it sort of flattened off at the end here. All right, and then I think what I'm going to do is I can just do a circular pattern on these. So let's select these 3 lines, select our center point here, and then I want 4 of them, and I just want them evenly spaced. Okay. It's kind of a chunky D-pad, but we could consider that with the tolerances, and then the D-pad one's actually in there should actually look skinnier. I think that's how that works. Wow, look at this. So easy. All right, I'm just gonna like extrude this, and then I'm gonna add fillets on the geometry. Sometimes when I put fillets on my sketches, because my sketches are all poorly constrained because I'm an idiot, they don't work so good if I have to change things. Okay, I was just thinking briefly, like, is the chin of the LCD gonna get in the way? But it's not, because the chin of the LCD is fully encompassed within this cutout. So that should be absolutely fine. Cool. So let's go ahead and get some chamfers, or fillets rather, not chamfers. And I'm probably going to do the smallest end mill I like to reasonably run is, it's about 0.8 millimeter diameter. 1/32 of an inch is what I actually use. So I think we're going to do a 0.4 millimeter chamfer on here. I don't want it to be too big. It kind of looks weird. Actually, we could go up to 0.5. Because sometimes you don't get a very good finish if your corners are like the exact radius of the end mill. Can't really do finishing passes there because it kind of just hits the corner and then it makes a hard like 90-degree turn in the other direction. So we'll make that a little bit bigger. I'll do it 0.5. All right, cool. All right, let me rename this real quick. Controls. Let me hop back into this sketch and let's work on A and B. It would be very funny if I do the 45 degrees apart B and A relative to the X line like I do on the Tad Boy and the Frog Boy, just to make people mad. I think after the volume wheel, that's like the second most common thing that people are like, just fine. We all have terrible opinions. Where do I want this though? I think, so what I'm gonna do is I'm gonna create, I think what I'm gonna do here is create a center line right through the middle. And then I'm going to mirror the point at the center of the D-pad across to the other side, and I'm going to use that sort of as the center of the A and the B buttons. I think that should work decently well. All right, and then let's say, yeah, and then I can have this sort of constrained by the sketch. So we'll do a 45-degree angle. Let's say 4 millimeters. That's going to be a construction line. And then same direction, 4 millimeters. And then that's also a construction line. All right, I don't know what this construction line is for. Never seen it in my life. And then let's see, how big can I get these? That's too big. Okay, I think 6. I think 6 millimeters is a good diameter for these buttons. Yeah, that's looking pretty good. I don't know if it's perfectly balanced, but I can move those later on. See, you're a little late for this, but renaming sketches is the kind of thing I would never have thought of. I constantly forget what the fuck it's for. I too, let's take a stroll through the Tad Boy file, or not Tad Boy, the TFC. Oh boy. I think I have 3 named sketches out of like 54 sketches. Oh my god. Wow, that's bad. This is why I'm releasing step files and everybody can work with those, because I don't want to show all my crimes and have them displayed forever on GitHub. Jesus. All right, let's go ahead and update this extrusion to cut that out. All right, that's looking good. And then I think for start and select, I'll do circle buttons because, as I mentioned before, I'm kind of going for a Tad Boy aesthetic instead of an OG Game Boy Color. So let's go ahead and pop back in here. We already have a center line here, so that's good. You know, these are going to be, you know, just mirrored across from each other. I think that's actually a good distance. So let's do 4 millimeter diameter. Yep, we already have our center line selected. Ah, no, that's actually... All right, let's do this. Let's say 3 construction line. So that means it's going to be the center of it's going to be 3 away from the. That might be too close, but we can adjust it. So let's see. Let me mirror this. I think that's a little too close. So I should be able to just come in here and adjust the size of my construction line. So maybe 3.5. Yeah, I think that's looking good. Hell yeah, okay. And then once again, we're gonna update this extrusion. I do recommend updating extrusions instead of creating new extrusions where you can just keep your timeline cleaner. I think that's the one good piece of advice I have beyond the, oh yeah, like maybe I should rename my sketches instead of just leaving them as the default. All right. Wow, this is actually coming together faster than I was expecting. Cool. So this thing will have a speaker. I don't think it'll have a volume knob, which pains me to say. I'm like, I know the TFC doesn't have a volume knob either. But I don't think I could get a proper potentiometer small enough that it would be a good experience. The only things I can think of are like trim pods, and trim pods aren't really made for that. I know. Oh, what's HDR got to say? My favorite fusion feature is when I get one face that randomly gets split into two faces for no reason at all. Yes. Maybe it's your center lines. I don't know why, but center lines do split extrusions, or they split faces. Which I don't know why you would want that. I feel like if you have a center line, it should be a construction line that is automatically selected for a mirror operation. Like, that's the way I see it. But these people, Autodesk, they work in mysterious ways. I would abandon them if their product wasn't mostly good, probably. But what are my options? More expensive things than FreeCAD. I think I'd rather kill. I think I would rather eat a poo. I don't want to get demonetized here. Then use FreeCAD. FreeCAD sucks. All right. Cool. So that's the buttons taken care of. I think the next thing that I need to do is probably start working on the back shell. I think the most important thing there is making sure that the positions for things are correct for cartridges. So let me pop back over here because that's really going to determine where the LCD or where the PCB is going to sit in the shell. Because the M.2 connector, I can get them in various heights, but they're all, there's only like three steps maybe. And it's going to have to be on the PCB as well. So I think the main determining factor of where the PCB is sitting sort of in the Z direction in the shell is going to be the connector. Yeah. Oh no, and I actually am locked into, I think, the 4.2 millimeter high connector, simply because I need all the clearance I can get for the cartridges. This is using TFC cartridges, by the way. I don't know if I mentioned that. So let me see. I think on a side note, it would be good for me to prepare a document or get separate GitHub repo just for this cartridge standard, explaining this is the cartridge size, this is the pinout, these are the sort of space you need in order to actually fit a cartridge into whatever cartridge hole you have in your design. That way people can, other people can take it and put it in their own projects. I think somebody, maybe Natalie the nerd, was talking about that a long time ago. So I don't know, maybe people could find that helpful. Word salad. What was I doing? Oh, yes. I need to find, where's my CPU board here? God, I've lost everything. Oh, there it is. Okay, so there's a CPU board. I think that's actually the wrong M.2 size. That's not super important right now. Now let me turn on the back. Okay, so we have a distance of, from the PCB to that 6.655. Okay, so I'm going to keep that clearance. Okay, so I'm going to go ahead and create a simple back half. Let's see, so I'm going to create a sketch based off this. I'm just going to clear any projected geometry because I don't want it interfering. I'm going to project just this outer part. No, stop. My shaky hands strike again. Not normally with these things, but sometimes. Okay. And then I can get a clean extrusion for the back off of that. So let's just say, how thick did I make this? 7.5, okay, that makes sense because I was going for a 15 overall. So let's do another 7.5 extrusion. We're gonna do a new body because I don't want it to be joined. Okay, alrighty. That's looking pretty cool, honestly. It's a little chunky boy. It's kind of reminding me, I think it's actually a little thicker than this thing. Whatever the fuck this, the hell. Family friendly. Whatever the hell this was called. I don't remember, but it's small and it's vaguely Game Boy shaped. Alrighty, so let's see, 6.65. We're just gonna say 6.65 for the clearance on that. Okay, and then I think that's got a 1 millimeter thickness on that back wall. I'll probably keep that. So what I need to do is, and this is always where I get stumped. Okay, so I think what I'm going to start with here is we're going to see, okay, what's the horizontal clearance that we need for a cartridge? 29.5. So I know based on the TFC that actually works very, very well. It's not too snug of a fit. It slides in there pretty well. So let's see, let's make sure we get our orientations correct here. So let's create a sketch on the back, and then starting from the top, I am going to, using a centered one just so I can get it like horizontally mirrored, we're going to do 29.5, and then, so normally, like on my previous designs, like the Tad Boy and the Frog Boy, I have the labels visible. I think purely because of the M.2, I don't want that this time, just because it's going to try and like, you know, lever itself out because those things are spring loaded. So I think it's going to be mostly covered in this case. So let's see, let's just say, I don't know, 12. So that's basically going to be 6 from the top. And then let's finish that sketch. Let's go ahead and extrude this down to, I think this is almost perfect now that I think about it. So I'm actually going to extrude this all the way through. 7.5, yes. And then let me make sure it's only cutting, yes, it's only cutting that one body. All right. I was thinking about the shield, but I do not need a shield because the PCB is actually going to sit right here at this level, right, sort of like flush with the top of the top shell part there. Which I think, yeah, that should give me plenty of clearance for everything. I think, yeah. Okay. Cool. All right, let's go ahead and turn the front off. I should probably name these. Oh, my body's okay. Front. I will create components from these later, but I'll worry about that in a bit. So let's go ahead and turn the front off. I'm mostly concerned with getting a big enough recess for my cartridges here. Okay. So basically we need space for the cartridge itself as well as the M.2 connector. So that's not like bumping up against the back or anything like that. So let's go ahead and measure. So let's see, from the back of this to the front of this. So that's where the cartridge will be flush with. That's about 32 millimeters. Okay, so I think I forgot to save this. Wow, could have lost everything. All right, let's see. Let's create a construction line up here just so we know where that top edge is. And then what I'm going to do is, shoot, what did I measure that as? Oh, 32, I think. Yeah, okay, so I said 34. So we're going to go 34 down from here. Where did my line go? That's 3.4, Jesus, okay. Alrighty. So that's going to be where the back of this recess is going to be. Let's see. So let's just pin it to this. Okay. I think we should add some constraints. So let's see. What constraints do I have on there? Coincident. Wow. Okay. So theoretically, if I move this now, yeah, that bottom edge moves nicely. Okay, and everything is still parallel. And actually, let me just mark these two lines. Oh, it's over constrained, whatever. I don't have time for this. Let me see, you know what? I think before I do this, I want to shell, because it's gonna be weird if I shell it afterwards. So let's see, same 1.5 thickness. This is almost certain to get a break something. Oh, it didn't break anything. Wow, look at that. Okay. Okay, and then let's see. We have, I just realized that's not at the right height. So I'm going to take my sketch and I'm going to redefine the sketch plane to the bottom. Okay, and then I can extrude it up 0.5 millimeters. Okay. So now that should give proper clearance for the cartridges. This should provide enough clearance for the M.2. Let me just, I mean, this looks like it's perfectly fine. So yeah, we got like 27.5 millimeters there. So shouldn't have any problem fitting the CPU and the RAM behind the M.2 connector there. Hello, Jubbio. Welcome. Alrighty. Wow. Okay. So let's see. I think what I want to do next is, I think I want to take care of the PCB part, because I think that's going to be pretty easy. So let's go ahead and turn off the back. Let's turn the front back on. So this is almost certainly going to be a 0.8 millimeter PCB. So what I'm going to do is, let's see, how much distance do we have there? So that's 6. Okay. I could reuse the sketch for the controls, but I don't really want to do that, to be honest. I am going to have to think about screw holes at some point. And I do need screw holes for the board itself. Let's see, where would be a good spot for those? May have to rethink some of this, but for now, we'll soldier on. I stopped playing Forza 6 to watch this. Wow, thank you. I know nothing about Forza, except cars go fast. Where battery? In here somewhere. Yeah, I think I'm going to use the same battery that I used for the TFC, which I think will fit just fine, actually. I think it'll fit on top of the battery. I might need to thicken out the back a little bit more, potentially, just to give it clearance, but, you know, with this about 30 millimeters, I think. One second. And then let's see, how many millimeters do I have in here? Yeah, I've got 35 millimeters in here. Yeah, so the battery is going to go in the back shell, right on top of the CPU. So similar situation to the Tab Boy. I have not, and I will tell you why after the stream, because I'm lazy. That's mostly why. But also I had a thought, so I will. Now where were we? Oh no, I've created all these sketches. Okay, let's see. So we're going to call this sketch backface. I'm going to take care of this before I proceed. This one's going to be cart peeper. Don't ask me why. This one's going to be cart, we'll just say inside relief, something like that. You know, something that seems marginally plausible, I guess. And to confuse people more, the thing that HDR refers to is a thing. It's a thing. I think I was going to say something that kind of spoiled things, but I won't. I shan't. It shan't be done. And then this one, oh yes, this was going to be screw posts. We'll say front screw posts. So I need to start planning this out. So I'm thinking, I think here in these two corners, that's where I'm going to put the screw posts for buttoning up the shell. So basically they'll go through the back, and it'll just hold the front and the back shells together. I'm going to have to figure out where to put another one. It might be that I have to, because there's not a lot of space up here. I think what I might do on the top is do some sort of interlocking mechanism with undercuts. So basically have some kind of ledge and a lip, and then you kind of like lever the back into the front there, and it, you know, it's kind of held in there by the undercut, and then you could have the two screws on the bottom. I think that's what I'm gonna do for that. So I'm just gonna keep that on the back burner. So I need to create little screw posts for the corners here. I'm going to use M1.6, I think. So I think 4x4 roughly should be good. Let me see. How big did I make the ones on this? The amount of times I have to go back and reference this, people are going to think I didn't actually design it. And maybe I didn't. Oh, shoot. They're 4x4. Wow, I'm so smart. Why did I make those construction? I don't want those to be construction. Okay. And then we're going to mirror it along this line. Okay. And now for screws for the PCB, I think probably, because let's see, how much room do I have here? 25. Oh, man. Because I was thinking maybe one here. I might just do one. It would be a lot easier if I could put holes through the board, like somewhere through the middle like they did on the SP. But I do not have the room for that. It's all chips. Let's see, are they SP buttons? No. No, they are not. They would not fit. This is very small. These are going to be custom buttons. I think I'm going to do, because I could do fully silicone buttons. I think that would be fun. But I think I might actually do standard like membranes with tack switches, and then the hard plastic or metal buttons. Could I put holes through the sides to hold the parts together? Oh, for the shell for sure. That was actually something I was thinking about. The only reason I'm somewhat avoiding it for now is because that requires more setups on the mill. So that would, if I do it this way, and I do like a lip and an undercut, I can actually do those using T-slot cutters. So it's almost like a cutoff disc. And you can come in and it can like do undercuts and things like that. So I could still mill this entire thing in just like 2 operations, front and back. Whereas if I put the holes in the side, then I'm having to do probably 4 operations at that point. So front and back, and then the 2 longer sides, so that I can like mill the holes out and tap those holes and all that stuff. And that would actually apply to front and back, because you have to have the clearance holes in the front, and then you have to have the actual tapped holes in the back. So you should get the Makera Z1. It looks very good. It's a lot of fun. I mean, I don't have that specific one, but the Carvera is a very fun little machine. And I have no doubt that their new one's going to be very, very cool as well. Yeah, let me see here. So I think the CPU is going to be mostly here. RAM's going to be here. I think I could put a screw through the board here. And I might be able to get away with one if I have something on the back that kind of like just presses on the PCB and kind of sandwiches it in there. I might actually be able to get away with no screws. Just have like little alignment indents. I might actually do that. Yeah, I'm gonna go with that idea for now. So, so let's go ahead and get these screw posts extruded out. So I think it was 6 from this inside bottom face to the top. So it's going to be 0.8 millimeter PCB, and this needs to come up fully to the top because that's what's acting as the cartridge shield. So 5.2. And then let me double check that. Yep, so 0.8. Gonna add fillets here just for machinability. So I think a lot of this work is going to be done with probably a 1/8 inch in mill. So, excuse me. I'm gonna do the 3.175, which is 1/8 of an inch in millimeters over 2. So there we go. I'm not gonna worry about like oversizing those fillets for the sake of like doing finishing passes and stuff, because it's inside. I don't care. Just weld the board to the housing. Don't tempt me. I will do it. Okay, cool. And then I think, just while we're here, I'm going to, and then I'm going to, I'm just going to mirror all these features. I want to do as much as I can with mirrored features. So if something moves, I'm only moving things once, in theory. There were definitely some people among the BitBuilt crew at MGC who are much better at this than I am. I would love their skills at CAD, but I am stupid. So there you go. I'll just plop a point right there in the middle. I'm gonna mirror that across. Alrighty, and then one of my favorite Fusion features, use the hole feature. All right, these are going to be tapped holes. Going to go with a, 1.6 millimeter isometric profile. I don't think I need them to be 5 millimeters deep. We'll just do 4. Luckily, I can get, I have drill bits that just let me drill the exact correct dimension. So I don't have to do a boring operation with an end mill or anything. And that's actually worked out super well for me. So. Yeah, stupid gang, indeed. How do we live with ourselves? All right. So that's that. Let's turn the... I did this backwards. Oh, no. We're going to pretend this never happened. Oh, my God, no. Oh, no. Stupid gang indeed. God damn it. Okay. I'd say it's it never... God, it's also misaligned there. This is terrible. Always pay attention to what you're doing. That's the wrong thing. I want to align. Boop. All right, and then let me... 2 there, boop, and then let me turn that back on. Did I do that in the right order? Yes, okay. That looks better. Luckily, everything is symmetric from one side to the other. Unlike the GBASP. Interesting choices they made there. Okay, let's see. So what was I doing here? I need... God, that's going to be really tight with the motherboard. I think it'll be fine, but... Yeah, that's going to be really tight with the motherboard. I'm going to double check my measurements. Oh, yeah. Oh, yeah, that's going to be good. That's going to be fine. Okay. Let's see. What was I thinking? Does anybody remember what I was doing? Oh, the PCB. I'm gonna make a mock-up of the PCB real quick. So let's see. Let's create another sketch. Let's do it on this plane. Get rid of all the projected geometry. I think there's an option to not project by default, but I think they moved that somewhere before I started wanting to use it. So no luck for me. Okay. All right, we got our projected lines. I'm gonna just turn this off so I don't have to worry about it getting joined. So let's do 0.8, and then we'll add probably a 0.2 millimeter tolerance for board size, because I think that's roughly what JLC promises with their standard accuracy option. You can actually specify, oh my God. You can actually specify smaller, but you have to pay for it. And I just, it's why? Why bother? I'd rather spend my money on useless tools that I'll use once and never again. All right, there is the PCB in place, or at least the mock-up of it. So really nice thing is that from Fusion here, I can export so basically a sketch profile. In this case, I'm going to create a sketch profile from this PCB. I can export that sketch profile to a DXF file, and then I can import that into KiCad as a board outline. So that makes it super easy to get things lined up. And then one of the other things I like to do is, so for like controls and things, I'll put like just like a drill point in the PCB at the center of those features. Make sure those are included in the sketch profile, and then like I know exactly where on the PCB I need to put my buttons and things. So that's a helpful tip for folks. And actually, you know what? I think I'll go ahead and do that. So let's go ahead and create another one here. I need to figure out, let's see. I need to project my features. And in this case, I probably will not actually have holes in the board. So I'll just remove those in KiCad once I've placed components, but it's nice to have in the interim. All right, I don't really need to worry about making these, construction lines because I'm not actually extruding anything from this. But why not? So I'll just create 2mm holes here. I create enough circles that you'd think I know the shortcut for creating a circle in a sketch, but I do not. Maybe there isn't one. Oh, there might not be one, at least not by default. Alrighty. And I think the good thing is there's a lot of room between the PCB and then the top of the shell. So there's there's crap tons of room. I think I'm going to put as much on that side of the board as I possibly can. Actually, I think I could probably fit a big ass battery behind the LCD. Oh my God. Wow. I'm going to consider that for sure. Okay. Let's see. Let's call this one button markers. This one was, let's see, PCB base. This was screw posts. Okay. Let's see, HDR. I've thought about getting a Stream Deck and setting up shortcuts on that for KiCad and Fusion. That would be very cool. I've actually thought about getting a Stream Deck as well. But not for that. I might do that. I'm going to steal your very smart idea. Okay, so that's the base of the PCB figured out. We got our screw posts here. I'm going to figure out the next part later. So I think the next part that I'm going to do here is I'm going to work on the sort of the mating surfaces between these. So I don't want them just like pressed right up against each other. This kind of goes back to what I was saying about the lens, where I don't want to be able to look through whatever tiny gap is there and see the internals. So just like you see on a Game Boy or whatever, we're going to do the little, I don't actually know what they call it, but this is what I'm going to do. So let's see, we're going to cut this down by 1mm. I'm going to extrude it up by 1 again. I'm going to create a new body. And then what I'm going to do is just select this all the way around. And then I'm going to offset this by, let's say 0.8. That would give us, I think if we do a 0.8 offset on the backside for the similar operation, that would give us 0.2 clearance. That's probably actually too much now that I think about it. No, that would give us 0.1. So I'm going to do 0.8. All right. Very good, and then I'm gonna combine these. That's gonna be my tool body, so we know which part is the main part. Okay. And then let's open up our back here. And so what I'm gonna do is I'm gonna extrude this out by probably 0.9. I don't want it to quite be touching. I kind of like the look of having just a slight gap there. I think it helps kind of hide the flaws a little bit if there's like any weird inconsistencies in machinings. Hello, old dearty. Which mayhaps you've never heard spoken aloud. I don't actually know if that's how you say that. Let's see. So I don't want to join. I want to do a new body. Alrighty. So let's see. Let's hide the front here. Let's hide the PCB because that's getting in the way. And then some more things. So we're going to select the inside faces. Okay. And then we're going to offset these by also 0.8. Negative 0.8 rather. All right. And so we're just going to combine these again, just like we did on the front. And in theory, as long as I did that correctly, yeah, that looks all right. Look at that. We can go ahead and load up our cross-section analysis here just to kind of sanity check that. Yeah, so you can see we have this sort of the inner lip on the front part, and then we have an outer lip on the back part. And so they'll securely mate together and sort of self-align, just like you would see on basically any housing, like electronics housing. Cool, cool, cool. All right, so that's looking pretty good. What do I need to work on next? So I think at some point, let's see. Let's see what it looks like with a back fillet. Wow, I want more than that. Whew. That looks pretty good, I think. Yeah, that'll do. Let's see. I think I'm gonna need, because that's a pretty thin wall there between the outer fillet and the inner sharp wall. So I think what I'm gonna do is, and I did this on the Tad Boy as well, so there's precedent for this. I'm just gonna create an inner fillet as well. The only important thing is that it doesn't interfere with the cartridge, and yeah, in this case, it's not going to at all. Cool. I think the only other thing for the back of it and screw posts that I need to do for now is I think I might want to sort of build these areas on the sides up so that the cartridge has a nice sort of slide path into the system. Yeah, that sounds about right. Okay, yeah. Now I just have to think about how I'm going to do that. I have one janky way that I always do this, and it's going to be this. So let's see, let's create a sketch profile here. Oh man, let me project this part because this is where I want to have it stick out to. I'm going to pull that in there. Just going to connect that to there. Okay. Yes. And I'm not going to mirror it for now. I'm actually going to see if I can just mirror the feature across. So let's extrude this down. Oh, wait, yeah, actually, I think I've got full clearance for that. Yeah, so I can just join that. Oh, hell yeah. That was way easier than I thought it was going to be. Okay. Yeah, I mean, shouldn't be any problems with machining there. There's this spot here. We need to add a, let's see here. Let me get rid of this for now. No! Okay, hold on. I was too early adding that, so let's go ahead and delete that. Okay. And then need to add a fillet here. Actually, first, let me make sure I mirror this feature across. Wait, no. That's silly. I'm not going to do that. Because I just realized this was way easier than I thought it was going to be. So we're just going to mirror these lines across. Boop, boop, boop. Okay, and then we'll update our extrusion. Just going to select this one. Yeah, there we go. Okay. So you probably dumb question about how would a cartridge ever fit in there? Yeah, time fog color cartridges. That is correct. I have no self-control and I ended up buying the stream. I'm curious, which version did you get? Because I saw they have like, I don't know, like 6 button versions, but that doesn't seem like enough. We're going to do the same one in half of 1/8 fillets back there. And then we're just going to fillet this whole internal feature here. So I think, yeah, I mean, I mostly use 1/8 bits for these things. So we're going to do, you know, use a 1/8 inch ball end mill for clearing out these sections here. And that's fine. That's just a straight through. Cool. This is really coming together. I think the interesting thing here for me is that normally with my previous designs, not so much the Time Frog, more so with the Frog Boy and the Tad Boy, I did a lot more test 3D prints for those. So I would make like the basic shape, the basic size, no button cutouts, nothing like that. Print it out, see how it was, add a few features, print out a prototype. And I think that's very good, especially if you haven't really done a lot of projects like this, because you don't really know what you're looking for. You don't know what's going to work and what's not going to work. I think nowadays I'm much more comfortable with just kind of like proceeding with a much more fleshed out design before actually printing or milling a prototype. I might actually just mill the first prototypes for this because that's what I intended to be made out of. I intended to be made out of, machined aluminum or brass or steel or, whatever. Maybe milled plastics as well. I'm not super concerned with 3D printing because I think FDM just kind of sucks for permanent housings. Let's see, what did the HDR get? The Mark II 15 key with scissor buttons. Well, now I'm curious, so I'm going to take a detour. I want to see how much that costs in Freedom Land. Stream Deck Mark II 15 keys. Okay. Oh man, that's way more reasonable than I thought. What? I like this knockoff one that has a knob. That's sick, dude. I like this real one with a knob. I could get this in 3 hours. Wow. I'm not going to, probably, but I could. Incredible. Well, HDR, please let me know how that goes. Let's see. When you cut that rebate to make sure you couldn't see the inside. You did that everywhere, but where you have the opening for the cartridge, you don't need that, do you? Which part are you talking about? You cut that relief to make sure you could see the inside. Oh, wait, are you talking about... That is, in fact, a very good call out. I see what you're talking about. Yeah. Thank you for that. I think that's one of those things that I would not have noticed. Cool. All right, let me see. Back, okay. Let's see, I do need the back, actually, because I need to project these points here. Yeah, that's great, okay. So this one actually just needs to come up to this. And then I'm gonna turn that off just so it doesn't try to join it to the back as well. Okay, and then actually I need a little bit of clearance there because I'm gonna need a fillet for machining. So let me go ahead and just offset these by like, I don't know, 0.5, 0.6 maybe. Let's do that because it's gonna be a 0.5 millimeter fillet. Yes, thank you, Mr. Viking Man. There we go. It's a little bit of a gap there, but that's, I can deal with that. I think, I might actually come back to this later because I could actually just round over this corner and then have this, sort of brought back by 0.5 millimeter, and then it's much more flush. I'm going to do that now, actually, because I know I'm going to forget that later. All right, let's see, 0.5. That's a pretty short run, so that shouldn't be a problem at all in terms of like what's reasonable from a milling standpoint. Let's see, what was that, 0.5-ish? Yeah. It's all about the fit and finish. Look at that. And then let me turn on my PCB just to make sure. Yeah, look at that. Wow. All right. I think there's the possibility for making this thinner, but I don't think I'm going to do it. I think 15 millimeters is fine. I think I'm happy with that. And it looks kind of cute and chunky, so. Egg Boy Color is such a flex of a name. Respect the dedication. Thank you. Thank you. All right, let's see. I think the last thing I had mentioned was, oh, actually, before I forget, this is another spot that needs a fillet for machinability. Yeah, we'll just do the same. Half of 1/8. I keep doing this. There we go. Okay. I think that looks better anyway. I may actually choose to take this down just a little bit farther, but I haven't done anything cool with like Time Frog cartridge labels yet, so I don't know if there's really a point. Cool, cool, cool. Yeah, okay, so I think the next thing is we need to get these screw hole things done. Screw bores, maybe is what we could call them. Let's see. So I think let's turn off the PCB here. Oh yeah, the PCB. Actually, I need to update that real quick. I'm just gonna reuse the button marker sketch. I'm gonna project these holes because I absolutely do need clearance holes for these on the PCB. All right, let me go ahead and just hollow those out. That's on the other side, isn't it? Here's 0.8, okay. So those are marked out. Those actually need to be a little bit larger. Actually, what is the M1.6 clearance hole size? Looks like 1.8 is considered a normal fit. 1.7 for close. I think I've done close before and it was fine. But I think I'll stick to a normal fit. What's our current size on this? 1.271. What? So what a weird size. Oh my god. Okay, let's just do -0.2. That's not big enough. What am I doing? 0.25. Okay. Yeah, there we go. That's roughly a normal fit. Okay. All right, so that's taken care of. And so the back here is going to come down and just like kind of rest there. Yeah, I think I'm just going to do indents on the PCB to keep it in place. I'm not going to bother with. It's kind of iPod-esque from the back. I mean, same is true of the Tad Boy. I did do that one Tad Boy where it had the, oh, what did I put on it? I think it was anodized aluminum black front and then a polished stainless steel rear. It's almost an identical size too. It's just like slightly thicker than an iPod Classic. And that was not on purpose, surprisingly. Jimmy is here. Wow, Gib is here. Frogs are dumb. Hey. Also for some... Oh, you. It's probably all the Asian food pictures I post. Let's see, Laser said, I think you forgot to fillet one of the sides on the back part. Let me see. I think think I've gotten all the required fillets as far as machining ability is going. This isn't a problem because the cutter is just gonna... Oh, here, actually. This one right here. That one needs a fillet. Can I get in there with a tiny tool? I think I'm gonna give it a smaller fillet. I'll just do 1 millimeter. That should give plenty of clearance from the cartridge. That shouldn't be a problem. Always good to double check these things. Thank you. The second thing caught on the stream. I should just do all my work out in the open from now on. No more surprise. Just drop projects that everybody already knows about. Let's see. So how do I want to do this part? I think what I'm going to do is... turn off the front. Okay, and then I think... okay, and then let's see. Let's start from here, from the inside, I think. God. This needs some construction lines. Okay, got a nice little cross section there. And then these are gonna have to be a little bit bigger because they need to have a clearance hole for the head. Alrighty, and then just need my center line. My very crudely placed center line. We're gonna mirror these across, same as always. Okay, cool, those are selectable. Let's select those. Let's see, can I extrude these all the way down without them bumping out on the outside? I can. Look at that. Not always this lucky. I really should stop filleting things before I've... God, I keep doing this. Now I don't remember which fillet that is. It's way back here somewhere. Oh, that's the outside. There it is. Okay. I'm really surprised nothing broke. Oh, God. All right. Oh, actually, you know what? I'm going to just use the same. Boop. 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 Alrighty, so that's good. And now I'm going to fillet this again. Designing for CNC milling honestly isn't that hard, but you got to remember all the rules. And sometimes you don't remember the rules. God, I really hope there's space for the CPU. I think there is. Like, I don't think it's going to be a problem. I think it'll be okay. This experience thing on YouTube stream makes no sense. Experience? Is there experience on YouTube streams now? Pair programming, but don't ever talk to me about pair programming. Jesus Christ. Oh man, my last job, that was a popular thing. It was like, maybe it's kind of fun socializing time, but Jesus Christ. Sometimes I just want to code by myself, god damn it. All right. Oh, did I extrude that out too far? No, that's good. That's exactly where it needs to be, actually. Okay, that's nice. Yep, that butts up right against it. Very good, very good. And then all I need to do now is, yeah, I need to get these. Yeah, how do I want to do this? This is how I'm going to do it. Sketch. No, I'm not going to do that. Hold on. I'm going to do this. I'm going to come in from this side. Let's see, gonna clear these out. Gonna project the screw hole locations. Alrighty. Let's see, let me realign this. So I'm actually going to just leave that as is because I'm not gonna directly extrude those. Okay, so first of all, pair programming makes me think of that one clip from NCIS. I want you to send me this. I don't know what you're talking about, but I want you to send it to me immediately. And then, do you make good money doing this? CAD and embedded. I make basically no money doing CAD and embedded outside of whatever I make from YouTube ads or like selling Tadboy parts in my shop. I am a software engineer professionally, so that is where I make my money. And it makes me eternally sad because I can't stand it anymore. Hopefully my boss isn't watching. Perfect, okay. So what I'm gonna do here is I'm gonna create these holes. I'm gonna go for a counter bore. Let's see, I need this for, okay, it's already set up for a 1.6 metric profile. What kind of screw is this? This is one of my peeves with Fusion is that their whole thread system is messed up. Like they're all hard coded in these XML files, and like if you want to do like a custom thread, or like if the counter bore size isn't quite right for the screws you have to like either manually adjust your model, or you have to like manually edit the XML to add a new thread profile or like drilling profile, and it's just not good, man. But what do I know? I'm gonna make that a flat drill end. I'm gonna have this go all, so that's gonna drill through the entire model. All right. Oh, this needs to be clearance because it's trying to do tap right now. Okay. That actually is a lot better than I thought. I thought these counter bores were gonna go farther out towards the edge, but that's actually quite comfy. I do like that. Okay. Yeah, I mean, this is what I'm talking about. Like you do like a counter bore, and like it's nice to have all these standard setups so that like, you know, it's like, oh, okay, you know, I'm using a cap screw or whatever. That's a lot bigger. I might do it. I think I'm gonna do cap screws. But anyway, they don't let you like adjust the counterboard depth. You have to do it yourself, which isn't hard. But I'd like to have it built into the hole tool, please. All right, so I want to bring these further down. Not too far down though, because one of the things that I've actually found somewhat annoying with the Tadboy shell on the back is that the counter bores in the same kind of location for the screws basically go all the way down to the bottom of the well, and they can be weak if they're in certain materials like wood, which is like not to say I'm going to make a wood version of this, although I probably will. But I just, you know, I'm gonna be a bit more conservative. We're just gonna bring it down, you know, maybe to roughly a little past the halfway point, maybe. So there's a lot of beef in those areas there. Let me see. I'm gonna add quick fillets onto these, or maybe chamfers. No, I don't like that. I want to fillet. Wow. Now it's like a pre-lap stainless, the opposite of a pro-lap stainless. Wow. Quote in quotes, professional software engineer. Yeah, it's kind of a laughable idea. You're not wrong. Software engineers are fake engineers. All right. Yeah, man, this is looking pretty good. Look at this. Wow. Definitely farther than I was expecting to get in an hour and a half, especially like doing this live on a stream. I was thinking, you know, by now I'd have a cube, maybe 2 cubes, done a shell operation mayhaps. All right, now let's see. I think the next thing that I need to focus on is these buttons, because if I'm gonna have membranes, I'm gonna need some kind of features inside the shell to locate those properly. but I should probably actually design the buttons themselves before I design the membranes and the membrane holdy bits. So I might go ahead and do that. Let's see. So I'm feeling good enough about these. I'm gonna go ahead and make these into components. I don't think there's really downside to making them components anyway, but you know, it is what it is. I ordered my McDonald's Tad Boy Color Happy Meal with a Zelda game. Still waiting. I don't know what this is. Does McDonald's have Game Boy related stuff right now? Hold on. Did I know about this? No, I don't think such a thing is real. Oh, okay. You got my hopes up and you dashed them. I shall never forgive you. What was I doing? Okay, yeah. So let's go ahead and start on buttons. Going to create a sketch profile based on the front. I'm just going to get rid of it. I just want them at that height. Let's see, and then I'm going to project. Actually, no, I don't want them at that height because then they're going to like interfere with stuff. So let me undo that sketch. I'm going to create an offset plane 10 millimeters above, and then I'll put the sketch profile on that. Okay. No, I don't want a sketch dimension. Oh, God. All right, let's project. Nope, I don't want to project that whole face. I only want to project what I need. There really has to be a shortcut for like selecting an entire chain. Like it knows how to do it. It's smart enough for like fillets and chamfers and all these things. So I'm sure there's a way. I just don't know how. I'll go ahead and project all of them. Okay, you know, I probably already had a sketch profile with those. Oh, but without the fillets. That's right. Okay. Oh man, I need to redo these. I don't even know. What is this? What is this one? What is this one? Back screw holes. Well, more back screw. Things are starting to go off the rails. This is way too soon. Buttons base. Okay. Cool. Let's see. Let's start with the D-pad. I think that's the most interesting one. Let's see. So I think. Let's see. How thick is this? That's 1.5. That's right. Okay. So I think probably have it come out by like 2 millimeters. So maybe 3.5. So that's going to be the 1.5 millimeters underneath, and then 3.5 outside. Let's see. I think radius is 0.5. I mean, that is doable. But I think I actually need to. I'm going to get rid of these for now. This is where my timeline really starts getting messed up, when I just start like manually deleting features from like projected geometry. And then I wonder why it's all messed up 3 months later when I'm trying to change a dimension. Okay. So I'm going to offset all these. Actually, no, not the end ones. No, the end ones as well. God, why? Why do you deselect? Blame my keyboard. Time for a new keyboard, maybe. Jesus. Nope. 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 Go. God. Okay. Offset by, oh, probably more than 0.2, because there's going to need to be room for kind of rocking around the Christmas tree. Let's do 0.3. Wow, why not make an image of a Tad Boy Color Happy Meal? I could probably get my sister to do something like that. She is quite the artiste. She actually did my profile picture before AI, long before. because I'm old, she's old. She's not that old, but sure feels like it some days. Let's see, this is going to be that flange. I'm just going to call it a flange that goes around. There we go. Let's make it 14. It doesn't need to be that big. Oh, but I want to make sure it's big enough that you can't peer through. So we'll do 15. Okay. Maybe just one. I think these are the kind of things that I'm going to have to like actually test at some point. I don't think there's going to be any getting around like printing off or milling out test ones for this. I'm also not looking forward to milling these. These are going to be actually, you know what? The setups for these, they shouldn't be too bad. The milling setups. I'm probably overestimating how awful it's going to be. I'm going to have to use like, yeah, okay, a 1 millimeter ball. That'll be just fine. That's only 3 millimeters, so I've already got tools that'll do that. Cool. Okay, and then now I'm wondering what I want to do for this. I could go for the classic. I think I'm going to go for the classic flat style because I was thinking maybe I would go for more a modern like dished. Like the entire thing is just like, project a sphere and then like chop that out of the top part so the whole thing is like evenly dished. But I think we're going to go old school on this. So that's too much. I want not too smooth. Although the thing with fillets and chamfers is I feel like they always look bigger in the CAD because I always design small parts and they're gigantic on the screen. So. Oh, what has HDR done now? I've a piece of software I made with random MOTDs yesterday, and it greeted me with the Xbox 360 is. Oh, Jesus Christ. Oh, God. Let's see. I think for the little divot in the middle, did I already have a sketch for? That's on the bottom side, though. Oh, but I can just project this whole thing. There we go. Did that do anything? Okay, there we go. Okay, now is it going to pick up on the middle point? Oh, there we go. We can make it work. Add that little divot in the middle. Is that actually in the middle? It is. Okay. Some weird optical illusion going in there or something. Okay, and then if I go down by 1, and then we can just fillet that with a 1 millimeter so that it's a perfect sphere, and then I'll fillet this by like only 25 or something. I might change that later, but we'll see. Okay, I think that's a reasonable stand-in. So let me go ahead and turn the front back on. Let me drop this into position and let's see what it looks like. Boop, boop, boop. I want to get this perfectly aligned actually. So I'm just going to use the align feature because it's already aligned in the other axes. So that should be nice and easy. What? I selected the wrong face. Good Lord. Is that, what? What is going on here? A line from here. Oh, it is. Why? It looked like it was showing it was clipping for some reason. But it's just fine. I mean, maybe that's sticking out a bit too far. But I don't know. It seems... It's probably for the best, actually. I'd definitely rather err on the side of it sticking out too far than not sticking out far enough. Especially because I don't know which switches I'm using yet. And those have like different travels, so. All right, so let's go ahead and work on a pivot for this. Now that it's in the position that it needs to be. So I'm gonna go ahead and get a sketch here. We're just gonna slap I think 2 millimeters for the pivot's probably good. Actually, I might do, I mean, this is another one of those things where it's kind of dependent on what switch I have. I'll start at 3. Something a bit chunkier that I can get a nice round over on. Let's see, let's check out the PCB. Oh man, oh, there's so much space. So much space. Oh, that's great. Okay, well, let's see. How much distance is there? 4.2. 4.2. That is, man, that feels like a really long pivot, but you know, whatever. And then this is 1.5. Interesting. I think, yeah, we'll see about that. I think probably just need to offset this down. Just make that whole thing like super thick. I might revisit like the distribution between the thickness of the front and the back halves. Because I really think that might be too much space. But like if I can fit a big battery behind the screen, I would be so happy. I think that would be the ideal situation. So I think I'm going to leave it. Thank you, X-Gastly. Don't let your dreams be dreams on the Tadboy thing. Yeah, especially because I don't know if I'm going to make any more lenses or not. I have some on hand, so I just need to restock my shop, but I don't think interest has dried up, but it's definitely much slower than it was, so I don't know if it's worth it so much. But the files are out there for getting your own lenses, so that's always an option. Man, this looks really stupid, but you know what? If it works, right? Ah, you know, I can make it less stupid by having a little circular thing around this built into the shell, and then like this inner part can just be brought down. And then this is like a much more reasonable size. But that's, I'll come back to that later. Let's work on A and B. I don't think I'm gonna key them. This is small enough that I don't think I'm gonna bother putting like text or anything onto the buttons. So I'm just not gonna worry about that. Let's see, so I think it was 3.5, right? And then this guy's so thick. That's 3 millimeters, okay. No, -3, okay. And then we're gonna new body this. Oh, this one actually needs to be shrunk a little bit. I think 0.3, that was my offset. I think it's 0.3 on each side. Or, I did a negative 0.3, yeah. Yeah, okay. And then I'll probably bring this up to like 1.5 millimeters larger than this thing. What is this at? This is at 5.4 diameter. This is at 6 diameter. 5.4, 6, 6.9. So I need offset by 0.45. That doesn't look right at all. Oh yeah, that's Oh man, I'm too lazy to do the math on this. Yeah, 1.2 millimeters. That's fine. Let's see, just gonna slap a 0.5 chamfer on that. Man, these buttons are stupid as shit. But not anymore. Oh, that was just the clipping with the front shell. Ah, man, I wish they could display that in a smarter manner. Ah, forgot to combine these. Okay, let's redo that align. Alrighty. Oh, I think that's actually too big. Yeah, there's not gonna be enough room for the other one. Well, no worry. Negative 0.1. That's probably okay. Oh no, that's definitely not okay. continues to go off the rails. Oh, what I could do is actually have a... Yeah, I think I know what I'm going to do here, actually. So I'm going to essentially have... Let me project that. Okay, so that's 7.834. That seems like a weird distance. I don't think I did that, but okay. Thank you, HDR. I shall. Thank you, Sean. Let's see, I miss pocketable game systems. It's so cool to me that Game Boys can be as small as a watch now. I mean, in theory, they didn't have to wait until now. They could have done it before. Let's see, construction line that. So what I'm going to do here is I'm just going to have like a flattened off side. Slightly flattened off. So let's see, let's go back along this line, like 0.2 or something. And then what I'm going to do is just going to take that out perpendicular to that construction line. There we go. Alrighty. And then we can just extrude this down. Okay, and then we'll just give that a little round over just to make it pleasant. All right, and then I think what I'm gonna do is, let's see, can I construct a plane? I want a mid plane, but I want it to be like through two parallel cylinders, or between two parallel cylinders. I don't think that's a thing. So I think what I'm gonna have to do is, oh God. So I'm gonna construct a tangent plane at 45 degrees. Yep, okay, and then I'm going to, what are they doing here? Oh, wait, no. I don't want to base this off the button. I want to base it off this. So I'm going to have a tangent plane through 45 degrees. Okay, that looks like it's on the back half. And then I'm going to create another tangent plane. Ah, God, it's not the same. Okay, where was 0 at? Okay, so I went negative 45 degrees. Okay, and then I can do a mid plane. Honestly, I sort of detest construction objects like this. They're just, I feel like they're a crutch. And yet here I am. Okay, and then what I'm gonna do is I'm just gonna mirror this whole body across this plane so that it's perfectly in that position. New body, okay. So this is gonna be B. And this is gonna be A. All right, look at that. Yeah, I think that's too tall, but I think I'll revisit that some other time. Cool. How are we looking overall? You know, I think I just realized I want to move this back. I wonder if I were to just update that sketch geometry. Update my cart paper. If that would actually be correct. Oh, it worked. Oh my God. Wow, this is such a rare day. Look at that. Let's turn our PCB on too. Wow. Look at that. This is coming right along. I might try to make it a little bit thinner, but I don't know. I think I'll probably keep it. I guess if I made it too thin, it might just be like impossible to hold. Is there a place I can buy the motherboard already made up? I'm not sure what the current state of things is right now. I'm assuming you're talking about the Tad Boy. Is that right? You can get back to me on that and I'll give you an answer. Let's see, rename my sketch planes or sketches. Let's see. So that's face, button, flange, D-pad, flange. Oh wait, no, that's D-pad, nubbin. Rocker, I guess, is a better term. That's the D-pad flange. And that is D-pad face, I guess. Hello, is it a new GBC project? Yes, the Froggo Advance is coming, I swear. But for now, this is like my low-key summer project. It's going to be a keychain Game Boy. It's very small. It's based on the watch internals and the screen driver software. It's going to be roughly the same size, but it's going to have built-in battery and stuff. And it's going to use the same Time Frog color cartridges. So, okay, yeah. So you are talking about the Tab Boy. Yeah. So I know there were. So there are people who make pre-made Tad Boys on Etsy. There's like Northwest Electronics. There's some people in Europe. I'm not entirely sure who. There was somebody who was selling just assembled motherboards on eBay at one point. I don't know if he's still doing that, but you could always check there. You made a Tab Boy color and you love it. I'm glad. It's I'm very, very surprised how many Tab Boy colors have been built. But yeah, so your other option, if you don't want to assemble the whole motherboard, but you have some level of soldering experience, is you can get either PCBWay or JLC PCB to assemble almost the entire board, minus the Game Boy specific components. So they would ship you the PCB with everything on it except for the CPU, the RAM, the link port, and the cartridge connector, which, you know, some of those are potentially the hardest parts. But, you know, it's worth a shot. If I could buy a whole kit for the Tab Boy and just screw it together and make it work, that would be awesome. You know, I think if you were to reach out to one of the people who builds assembled Tab Boys, they might be willing to sell you just like an assembled board or a kit. There's Pizza Handhelds who does cases, so you could reach out to him for the shell. Yeah. And, you know, feel free to hop into my server too, my Discord server. I think most everybody who's building them is in there. All right, well, we're at like the 2-hour mark, so I think I'm going to call it here. I'm pretty happy with the progress that I've made. I think it's looking pretty good. I am curious though. Let me see if I can drop a Tad Boy shell in here for scale, just for fun. Let me see. Where is it? I don't know what this file called TBC Pocket is, but it looks about right. Let's wait for it to show up here. Wow. Oh yeah, this is like a slight modification. Yeah, so it is quite a bit smaller. I am quite pleased with that. It's, you know, thickness is pretty comparable, but I think that's okay. Especially if it lets me put a decent sized battery in there. I think that's more important. Man, it would be cool if I could get like a magnetic, like pogo adapter for a link port as well. I'm gonna have to think about that. No chance in hell. No chance in hell that I'm fitting an actual link port in there, but you never know. Also, this Tad Boy revision that I was working on is actually cooler than I remember. I might try making one of these just to see how it is in person. Got kind of some angular stuff going on. Anyway. All right. Thank you for joining, everybody. It was a pleasure to have you all. I will probably schedule more streams for this. You know, maybe bi-weekly, something like that. I think going to continue with the CAD for just a little while. Basically want to get to a fully functional shell. But we'll definitely do streams of like the electronic stuff as well. Programming, maybe not so much. I don't know if that's super interesting for people, but you know, let me know in the comments. Let me know in the chat. You know, come onto my Discord server. I put up a poll for this one asking what people wanted me to stream about. And so yeah, you know, just let me know there. definitely be doing it again. Great stuff as always. Thank you. Yes, my son Warner. He was a very good frog. I was doing some research today, and I'm pretty sure he was probably like 2 or 3 years old when I found him. So he lived to be a healthy, 16, 17 years old, which I never expected at all. Never knew that tiny frogs could live that long. That tad boy is gigantic, yes. Cool. All right. Well, thank you, everybody. See you next time.